Alright class, today we're going to look at graphing secant and cosecant. We're actually going to skip this review because we're going to be reviewing these curves when we do them in the problem. So we're going to go right down to the unit circle. So the normal sine curve is the reciprocal of the cosecant curve. Okay, so remember for the regular sine curve, these were at these angles, these were the coordinates. So like pi over 2, at pi you had -1, 0, and then at 3 pi over 2 you had 0, -1. So remember when we graphed this before, so I'm going to graph again just like we did back in Unit 2, a sine curve. Remember sine goes from 1 to -1, actually both of them, sine and cosine, do that. And sine starts at 0, the node line. So the regular normal sine curve looks like this. And I'm going to dash it this time because we don't really want to graph sine, we want to graph cosecant. Now remember, cosecant is the reciprocal of sine. So let's talk about what's happening at these zeros. You can think of this point as 0 over 1. So if you flip that, you get 1 over 0, which is undefined, which means that at any place the graph hits the 0, so at 0, pi, and 2 pi, there are now asymptotes for the secant or cosecant curve. The other thing we have to note is that when you flip over 1 up here, 1 flipped over is still 1, and -1 flipped over is still -1. So that's going to be on the graph. And then finally, just so you guys know where this is 1/2, right? So at this point on the curve, it's 1/2 for the y. So that's for sine. If you flip that over, you get 2. So that's up here. And then same thing over here. So what happens is, for cosecant curves, they start at 1, -1, and then they go up forever, approaching those asymptotes you drew in. So the blue graph is the only graph we really care about, and that is a one cycle of a cosecant curve. Okay, so again, here's what you do. You graph your sine curve like normal. Wherever it hits the node, that's where you're going to put your asymptotes. So in this case it was 0, pi, and 2 pi. And then on the crests and the troughs, that's where you start your graphs, and then you approach the asymptotes. So again, let's fill this in. So sine and cosecant are reciprocals. If we take the reciprocal of 0, we get a value that is undefined. Therefore, the cosecant graph will have vertical asymptotes at these points. They will occur specifically at 0, pi, and 2 pi. Now, again, that's only for the normal curve. If you decide to, or if we have problems where we shift them, then it'll just be wherever it hits the node line. Cosine goes with secant. So again, 0 to 2 pi, pi over 2, 3 pi over 2. We don't really need to look at the unit circle if you guys remember this. Remember how we started cosines at the top or bottom, and since it's positive cosine, we would start there. So this is what a positive cosine curve looks like. Okay. Again, secant is the reciprocal of cosine, so wherever it hits the zeros, that's where when you flip that over, you're going to get these vertical asymptotes. And then just like the cosecant curve, it's still going to be at 1 and -1, and then you just approach the asymptotes. Now, since it's kind of shifted over, the upper one is split in half, so we have half of it going that way, half of it going that way, but this is one cycle for secant. But same principle, look for where the sine and cosine curve hit the 0, or the node line I should say, and then you will be able to draw in your asymptotes. So the cosine function and the secant function are reciprocals. If we take the reciprocal of 0, we get an undefined value. Well, I guess we don't really get a value, it's undefined. Therefore, the secant graph will have vertical asymptotes. at these points. These will occur specifically at pi over 2 and 3 pi over 2. Again, once it shifts though, it won't be there. So now, everything we did before is going to be the same, except for the very, very end. We're still going to graph these curves how we did. So I see that this is cosecant, so I'm going to write sine here because I know that that's the reciprocal of cosecant. Now I'm going to get all my pieces that I used to get. The amplitude is 2. The node is at y equals 3. Remember, the node is the last number. The crest and the trough, the highest and lowest point. You start at 3, you go up 2, you get 5. You go down 2, you get 1. And then we make our inequality for our frequency and our phase shift. And this will go between 0 and 2 pi because that's what a cosecant and a sine curve do. So the first thing you do is divide by 4, and that'll give you the period. So the period is pi over 2. I'll write that here. The interval that we're going to go between, if you add pi over 2, you get pi over 2 to pi. And also the interval between spaces. Remember this. There are 4 pieces for one complete cycle. Is pi over 2, the period, divided by 4, which is pi over 8. Okay. So this is all what we did in Unit 2. So now I'm going to draw my graph. This is pi over 2. This is pi. I'm going to subdivide. So if my interval is pi over 8, if you add 1/2 and 1/8, you get 5 pi over 8, 6 pi over 8, and 7 pi over 8. So we have 1, 3, and 5. You box it. So that's where my cycle is going to be. It's a sine, positive sine, so it'll go like this. Oops. So if you dash the sine curve that it would be that. Now remember, everything I've done so far is what you did in Unit 2. Now is where the new stuff comes in. I want the reciprocal of this sine curve. So wherever it hits the node is where the asymptotes were going to be. And then we start the graph at the top and go up forever towards the asymptotes, and then the bottommost point and do the same. So the green curve is the cosecant curve. And that's it. That's the only extra step you have to do from before. So let's try one more. This time we're in degrees. So I see secant and I think cosine. My amplitude is just 1. The negative sign comes in later when we're graphing. The node is y equals 1. The crest and the trough are 2 and 0 because you are going up and down from 1. What else do I need? My inequality. This is in degrees. So we are now going to divide, so you get 40 degrees is the period. Now we're going to shift it 50 degrees to the left. And if the period's 40, the interval is 40 over 4, which is 10 degrees. So this is actually some nice math here. So I have negative 50, negative 10, middle, middle, middle. If they're going up by tens, this is negative 40 degrees, negative 30 degrees, negative 20 degrees. Zero's over here. 0, 1, 2. So I'm going to draw the box now. The bottom of the box is down here. It goes to 10. Goes up to 2. Alright, so there is my box. Now it's a negative cosine curve. So that means that for negative cosine I start on the bottom and work my way back up and then down. Alright, so there is my curve. Now, just like before, everything we've done so far is the same as last Unit 2. Now we just find where it crosses the node line, and we do this, and we do this. And then the last step is to graph the curve. So you find the highest and lowest points, so that you graph it there. Now this is the one where it's split in half, so we do that half here, and this half there. So that is the graph of secant. Okay, good. So that is all the information you need.